Welcome to our third of our 2023 Resilient series. Thank you so much for showing up on time. Sorry, we are late. So my absolute honor today to maybe bring in a different way of thinking. Each of our series is trying to open our minds to new resilient mechanisms, resilient toolkits, and I want to open your mind to an old one. Through Kama Aina, a man of the land of Hawaii. And let's just see how this goes, but take it away.
All right. Okay. Mahalo nui for joining. My name is Keolu Fox. I'm a professor here. I'm the co-director of the Indigenous Futures Institute. How many people knew that we have this here on campus? Besides our lovely MC. Okay. Well, now you know. Now you know. Our whole focus here is taking distinct elements like indigenous knowledge systems and recombining them with cutting edge tools like genome sequencing, genome editing, remote sensing, urban planning, and coming up with new alloys and forms of innovation. And I'm going to talk to you a little bit about those perspectives and ideas today and some of the projects that we're working on. I'm from the Big Island of Hawaii, and I'm a genome scientist. I'm the first Native Hawaiian person to get a PhD in genome sciences, which is both sad, lonely, and we're also hopeful that we're going to make some more. And I have a PhD student here who's also from Hawaii, so we're working on number two. But I just wanted to explain that we have this just lovely new way of thinking about things, right? Of thinking about what Indigenous futurism is. How many people have thought about futurism? A few? This campus is actually an illustrious place for that. Kim Stanley Robinson went to school here. Probably the most preeminent science fiction writer on planet Earth right now. He's a futurist. He focuses on climate futurism. We also have Octavia Butler, spent time here. Afrofuturist, extremely famous. David Brin, another good one. Angela Davis, activist, Afrofuturist. Craig Venter, genome scientist, futurist, thinking about precision medicine and health. I can go on and on and on about all the extraordinary people that are really taking the time to forecast and think about that. And if you know anyone else, let us know, because we're hiring. We're hiring at least 8 new positions focusing on design and designing just futures. And that is in a range of things from theater to computer science, medicine, oceanography, global health. And if you're wondering what that means and what the historical context of that is, look no further than Hawaii. Who's been to Hawaii before? All right. Where'd you go? Maui. Anyone else? Maui's burned down now. Anyone else? No? Did you learn anything about our history when you were there? It's complicated. It's complicated. It's complicated. But did you know that we created color newspapers, the first in the world? Did you know that we had electricity in Iolani Palace well before the White House? So you probably you participate directly in either one of 2 industrial complexes, tourism or the military. But we have a rich history of innovation. We created universal healthcare. That's another one. We had that one going for us. Queen's Health Systems, 1859. Many, many, many ways that we have utilized and thought about the future. I'm from this area on the northern tip of the Big Island called Pololu. Anyone ever heard of Pololu or Kohala? I know you have, but beautiful place. The Big Island, or what we call Moku o Keawe, the Island of Fire, is a biodiversity hotspot. One of the most biodiverse places in the world. It has the most diverse soil regiments in the world. Green sand beach, black sand beach, white sand beach, pink sand beach, red soils. It's truly remarkable. Truly remarkable. But it's also simultaneously the extinction capital of the world and the invasive species capital of the world. And I'm not talking about tourists, I'm talking about frogs, I'm talking about bacteria. I'm talking about Home Depot being at the root of bringing a lot of different insects and other things. And what that does when you have an extremely fragile ecosystem is what a lot of tropical islands are, is it degrades, it denigrates the biodiversity over time. So that's something to think about in terms of many of the things that you're designing. In terms of thinking about resilience, biodiversity and biocomplexity are resilience, okay? We can talk about that a little later. Hawaii is also the most diverse place in America for human beings. We have the highest percentage of admixed people in America. We produce the highest percentage of professional athletes in America. Mokuokeave is the most diverse county in America, my county, followed by Maui, where you went. Kauai is number 4, and then Honolulu County is number 11. And this is a heat map of a lot of the different most diverse cities in Hawaii, and you can just kind of see that tapestry. And the first people to get there were my ancestors, the greatest voyaging people, seafaring people in human history. Who wants to argue? That's good, because you don't have a microphone. But I don't think that that's negotiable. However, if we look back at the history of how our accomplishments have been represented, you'll find that the recognition of that was not a very popular thing. And one of the things that happened is this man, Thor Heyerdahl, popularized the narrative that our ancestors actually came from Peru across the Pacific and ended up in places like the Marquesas, the Tuamotu, Mangareva, Pitcairn Island, etc. Is that the right direction? Anyone? What we now know is that human beings originated in Africa, came out through the Fertile Crescent, branched out in a number of different directions, including identifying places in Europe, Asia, down into Taiwan, then from Taiwan into the Bismarck Archipelago, then from the Bismarck Archipelago onto the original moonshot, which is the development of catamarans and trimarans for transoceanic voyaging, where our ancestors utilized all forms of ecological metadata, including and not limited to bird migration patterns, the celestial sphere at night. So while all these Europeans were fumbling around understanding that no, the earth is not flat, we knew that well before Magellan. That's how our calculus worked when we thought about the stars. We knew that if there was a green glint on the bottom of a cloud, it meant that it was reflecting land and the location of land from a lagoon, from distance, from 300 miles away. This is how we utilized and could kind of identify some of the most far-flung island archipelagos on our planet. Okay? We were not helpless. We did not come from this direction. We did not float over helplessly on rafts from South America. We did identify South America 1,000 years before white people. That's for damn sure. We did identify Antarctica 1,000 years before white people. That's for damn sure. All that's documented. But the narratives that get popularized force us to be resilient. And so with Thor Heyerdahl, he set out in the 1940s. And what he did do was interesting. It's called the birth of experimental archaeology. That is, he created a raft and he floated it over from Peru in an attempt to get to the Marquesas. He was obsessed with Fatuhiva, Nukuhiva, and places like that. But what happened was they ended up destitute, stranded, and needing to be rescued, which is not our case. That was not our case. Even in Moana, we never starved. We had a pig and a chicken on the boat, right? So what you're seeing here is the popularization of narratives that were not true. This is the perception of our accomplishments for a long, long time. And so for us in our field, there were the birth of a number of things. I think Hokulea is coming here this next week or next month. Is anyone familiar with Hokulea? So in the 70s, the Hawaiian people, we decided to build our own boat and go the actual direction. We decided to sail from Hawaii to Tahiti to demonstrate to the rest of the world that that's what our ancestors did. It was a huge success. It was documented in every which way. The boat is called Hokulea. It's about 63 feet long, and it's coming to town, and you should check it out if you're in town. But that was resistance and resilience in response to this man's kind of theory that got popularized, which was completely wrong. And there's all kinds of archaeological evidence supporting the fact that our ancestors did that. There's all kinds of linguistic evidence. I mean, we can go through all the empirical ways in which science proves that that's the case. And one of the ways that I became science famous is that I used the human genome along with the community members from many, many different places in Polynesia, including Rapa Nui or Easter Island, Aotearoa or New Zealand, Hawaii, Tahiti, and others. And we worked in community and co-designed a study to sequence the genomes of our people to understand our diaspora. And it wasn't just me, it was a huge team of scientists. We published the work in Nature, which is always nice. And what you'll notice is that the names of the islands that we've used in a lot of our data reflect the language that we personally use. This is how we call these places. That is also a form of resistance because we are describing this in our way. I also got to write this piece in Scientific American where I got to use my language. And we said, and we have a saying that is "Ikawa mamua kawa mahope," and that means that we are walking backwards into the future. That means we're acknowledging the mistakes we've made. That means we're acknowledging our history and we're identifying these signatures of natural selection in the human genome, and we're able to create high resolution maps of our migratory history, the timing. And it's really beautiful to do that. And that was one of the biggest goals that I set out to do when I was a graduate student. It's one of the biggest projects that I wanted to work on. And this work is ongoing, okay? However, the vast majority of genomes that are sequenced today, they come from Europe. 95% of people that have had genomic inquiry performed on their genealogy come from Western Europe. So that means that every taxpayer dollar that goes to the NIH and the NSF and many other things that are used to create data sets that are supposed to build out the future of precision medicine privilege one community of people. Look around this room. It's extremely diverse, just like the University of California, just like the state of California. It is not a reflection of the diversity that we see every day in this country. So how did this happen in 2023? You know, now a statistic that is even more concerning is this. 72% of genetic discoveries have taken places in three places, in three countries. One of them is America, which shouldn't surprise you. One of them is the UK, and the other is Iceland. And that's mostly because Iceland has a kind of required genome sequencing phenomenon. They're an interesting place. But that means that among many places, the most diverse continent for genetics reasons, which is Africa, our origin, what do you see? It's bare. It means that they're being forced to outsource their genealogy to other places. Does that sound familiar to you? Does that look familiar? Does it look like other research-related relationships? Cobalt, perhaps? Who's ever read The Heart of Darkness? Put your hand up. Is that it? That's sad. Your required reading this evening is Conrad's Heart of Darkness. It's short, people. It's a short one, but it's a really good book. And what happens when you have countries that are not intimately involved in the culture of other countries, you get bias that is produced and reproduced over and over and over again. And this is from today. I think this paper came out on the 6th on the archive. It was recently published. And it says, fair coins tend to land on the same side they started. Evidence from 350,757 coin flips. So this is hot off the press. That even something that's supposed to be 50-50 is biased. So what does it mean when people that aren't from a community or culture get to analyze the genomes of a community they're not a part of? What does that mean? What are the consequences of that? What types of bias are represented there, right? Think about the whole field of machine intelligence. Who's heard of machine learning? Put your hand up. Okay, good. Yeah, all right, good. Deep learning, neural nets. Who's doing the coding? You are. What languages do you program in? Python. Anyone else? Python. That's your generation. No, I'm teasing, but that's good. That's good. How many computer languages were created by indigenous people? That's what I thought. Actually, one that everyone uses, R, was created by a Maori man by the name of Ras Ihaka. And that's pretty awesome because that is the indigenous way that people think about scripting and digital ecosystems. It's one of, but it doesn't mean that we can't come up with new ways to think about information science and big data, machine intelligence, etc. Okay, just wanted to point you in the direction of how bias manifests. There's also this little wrinkle. And this wrinkle is that 45,000 patents have been filed worldwide that mention DNA sequencing. This is Illumina. Who's been to Illumina's headquarters? Good. That is the largest service provider for genome sequencing on planet Earth. It happens to be based here in La Jolla, California. It's also a $40 billion market cap. It's probably lower. They just kind of had, they messed up. But these are patents on the wall of their cafeteria, lined up like a bunch of moose heads in a shooting lodge, right? A hunting lodge. That's what it looks like to me. This is how we reward capitalism in California. No one is thinking about the intellectual property and patent claims that are derived from people's genomes. So if it was oil before, now it's data. And it's extremely valuable. And it is so valuable that it is literally the bedrock for many different startups and whole industries that are developing new therapeutics all over the world. And we're going to dig into that a little bit. What does this look like to everyone, students? It's a bank. This is a bank. This is a bank that has been repurposed into a data center. Okay? We built a server in here in collaboration with the good people at NVIDIA. And I want to show it to you because it's both a tour of an old bank, but it's also a commentary and a piece of art on how valuable data is. Data is now the number one most valuable commodity on planet Earth, surpassing oil in 2018. And we need to start thinking about data as a resource. We have to educate communities. So when we have cities like Keolu, where we have a really high percentage of indigenous people who live there, we're like, yeah, come check out the bank. We want you to understand how valuable the information you're producing is. It's very on the nose, but it's very clever in a lot of ways. We get them to feel how hot it is in the room. They get to feel a lot of things that are going on in there because then it forces them to make this relationship. Now, when Tim Cook gets up there and says, hey, this new watch we're making, it's carbon neutral. Who believed that? Put your hand up if you are familiar with this. Who has an Apple Watch? Okay, you do. The new Apple Watch is supposedly carbon neutral, right? But how is that possible if the primary component that is powering that watch, the integrated circuits in that watch, is from the Democratic Republic of Congo? If it's from the copper belt, the cobalt belt, and it is a part of the most deplorable, dishonest, morally corrupt supply chain on planet Earth, then how could it ever be carbon neutral? Because there was an offset model? So I'm trying to get you guys to think deeper about what that means. Do you think that Tim Cook has ever been to the Democratic Republic of Congo to literally check out the bottom of his supply chain? No, he hasn't. And that's why we produce these pictures using AI, using Midjourney. We developed images of him visiting the Democratic Republic of Congo. Look at the fingers. You can tell it's not real. But this is the power of art. This is the power of resistance. This is what we do when we don't like something, right? We want to put pressure on him to visit. We want to put pressure on him to acknowledge the sovereignty of really important resources in places like that. And that is why the sovereignty of data is really important, because we don't want the supply chain that is present, that is going on, where we're extracting genetic information from indigenous people, we're sequencing it becomes part of this big data surveillance ecosystem, and then our people are left with nothing, right? In the case of the Model T, and the development of that, how many dollar bills do you think Amazonian people got in the development of this? Even though Ford had bought thousands of acres of rubber trees, he had vertically integrated the development of all of the components and tools, right? Every ball bearing, every piece of leather was on a supply chain. It revolutionized transportation. He made a lot of money, but ecologically, we got left holding the bill. And there's a legacy to that, right? So when we think about existing supply chains and emerging supply chains, what does that mean for genomics? What does that mean for the development of new therapies in the future? And from one Amazon to the other, we have another extremely powerful company that knows this as well. And they will literally send this snowmobile to your laboratory and have your data transferred onto their servers because they know it's the most important commodity on planet Earth. And with the emergence of AI and machine intelligence at large, that data is more valuable than ever. Okay? So knowing that, we started the Native Biodata Consortia, the first biobank and genome sequencing center on a reservation in U.S. history, where we are vertically integrating all of the components necessary, where we are providing cloud access to many different indigenous partners in resistance because our partners are not comfortable with their data being stored and accessed on Amazon Web Services, right? And if you're interested about that, you can ask me or you can check out our webpage. We're grateful to the support of many individuals, including the MacArthur Foundation. We also started Variant Bio. This is a biotech company where we work directly with partners, only indigenous communities. The difference between our company and why it is in full resistance to the whole biotech community is that we provide 4% of revenue and profit to community members for each individual project. It is completely disruptive when you think about what Regeneron and somebody like 23andMe is doing. 23andMe is selling your data to GSK for $300 million. And you paid them $150 to tell you what your grandma already told you. That's really dumb. We also provide free access to the drugs that we are developing in clinical trials to our partners. Unprecedented. If you're looking for internships, please let me know. We are into bringing tools into the field. That is point of care technology, bringing new ways to collect phenotype information in some of the most remote places on planet Earth. like this myoton, like these these paper-based diagnostics for different immunological phenotype readouts. We're reimagining what laboratories look like in remote places. Shipping containers have revolutionized supply chains. Moderna and BioNTech and many other companies are exploring what it's like to eliminate cold chain obstacles by bringing their miniature vaccine mills to places like sub-Saharan Africa. Really cool stuff. We've been thinking about these ideas as well in partnership with Queen's Health Systems in Hawaii through our Hola Hola Health program. And finally, I just want to leave you with one last thing. In 2020, the world generated around 59 zettabytes of data. Okay? It's estimated that by 2025, we're going to probably generate around 175 zettabytes of data, right? A lot of this comes from our utilization of social media, the Internet of Things, genome sequencing, Zoom, large language models. A lot of it is stored in data centers all over the world, including Amazon Web Services, Google Cloud, Microsoft. And a lot of that is being accelerated by the utilization of the GPU. Who knows about the GPU? Put your hand up. This is NVIDIA's, jewel in the crown, okay? The A100. This is the integrated circuit that is behind a lot of machine intelligence processes. And it's actually a problem too. Because when you accelerate computation and data storage, you also accelerate the amount of heat that is produced. So who knew that storing data and generating this much data is not independent of the second law of thermodynamics? Put your hands up if you've ever made that relationship, that computation is bad for the environment. It's okay if you didn't. I didn't think about this until my dad said that we're cooking ourselves. And I had to think about what that meant. But he's right, because processing this much information is not good for our planet. So everybody's focused on carbon. They're focused on one variable. They're focused on greenhouse gas, but they're not focused on this other looming variable. And I got into an argument with my friend from NVIDIA, and I said, I think that we're going to reach a new singularity. We're going to reach a moment when computation itself surpasses fossil fuel production as the number one contributor to the climate crisis. I think it's going to be within our lifetime. Who thinks it's going to be within our lifetime? Put your hand up if you think so. 5 years? Okay. That's ambitious, but okay. So we took this Enrico Fermi approach. Has anybody ever heard of this guy? You have? God bless you. You? All right. He is a really famous physicist. He would come up with all these incredible calculations. For example, he'd say, how many toothpicks does it take to reach the moon? Or how many piano tuners are there in New York City? Or he famously had an envelope in his hand during the Trinity tests, and the force of the bomb blast knocks it out of his hand. And he calculated the force of the bomb based on the distance that the envelope traveled. That kind of stuff. So we wanted to do the calculation, right? Some back of the envelope math. We wanted to know, when will computers create more greenhouse gas emissions than fossil fuels, right? When do you think it is? When are we going to reach the new singularity? And the answer is, these are just our estimates. This paper is in review. That's somewhere around 2050, so you weren't that far off. And we did a number of different comparisons. Really, it's probably between 2050 and 2078. Optimistically, that's within a lot of our lifetimes, if things go well. But that doesn't mean that we can't resist this. It doesn't mean that we can't hold data centers responsible and accountable. It doesn't mean that there aren't new and emerging technologies that will allow us to store data in more earth-friendly ways, what we call earth-friendly computation. And there are a lot of different technologies that are out there where people are thinking about this. Simple things like incorporating renewables into data centers. Something called saltwater air conditioning. So these are basically cooling coil valves that come off of data centers. Microsoft at one point tried to create a data center underwater because they knew this was coming. But financially, they were making too much money to actually implement new technologies. Data compression and deduplication. Who's taking 900 pictures of the same piece of steak and posting it on Instagram? That's everybody here. Edge computing, that is bringing computation, decentralizing it and bringing it closer to the source. These are all forms of resistance, forms of innovation. But my favorite by far is DNA computing. Because what is a genome other than a storage device, right? And a lot of people have been thinking about this, harnessing DNA as this storage device. So one of the people that kind of created this field, the synthetic approach to it, is here on our campus, and that is Craig Venter and Chris Glass. They created the synthetic cell paper in 2010 or 2011. And then a second paper in 2017 came out from George Church's group. Hate to give that guy credit for anything. But here you can see the storage of a video, the first video that's ever taken. Are you guys familiar with this video? This is the Murray Bridge video. Broken down into individual frames. Each frame is broken down into a pixel. Each pixel is broken down to a significant or codex or key of nucleotides representing that pixel. So what you can do is break down each individual frame into strings of DNA. And then you can use CRISPR-Cas9 to edit it into a benign place in the genome. And you can actually store this video in a single cell, in this case, E. coli. And next to it, I've placed a whole bunch of breadfruit on server racks that I made, art I made for you. Because I think that it would be even cooler to store data in the genomes of things that are carbon negative, that photosynthesize, like plants. That's resistance. So how do we get there? How do we get to a place where we're thinking about carbon negative data storage? When and where will that happen? What types of technological breakthroughs do we need to break into to get to that level? And that is an Indigenous futurism idea, because we know that we can't just have a data storage center at our NBDC biobank and tell people that they can store data there and know that it's bad for the environment. That would be against principles around sustainability. So I just kind of wanted to wrap it up there and say thank you so much for listening, and we will take your questions.
Thank you. I'll hold this. You can hang out there.
Oh, okay, cool.
How many people had their mind a little blown today? Just, yeah, let's be honest.
Put it up hot. No,
let's be honest.
But I do have a question for you.
Please.
Wait, not yet.
Uh-oh.
You'll have your turn, and you'll get a mic when you do.
Mm-hmm.
We're going to do another minute because Keolu's got us moving. And so he's used the word resistance. People have started to realize this can be a good thing. What he's saying is resist bad things. And he's also told you, and I'm not sure you realized when you look a little harder at what his people were doing when Europeans were kind of still deciding whether or not it was worthwhile to take a shower. So I want us to just for a minute, and maybe let Keolu ride the wave, and we'll see what happens. So imagine if Keolu's people actually held the reins a little longer. And we had kahunas running our global health system.
Love it.
And we had a culture that's had carbon neutrality and really building both their culture and stability into nature for a long time. So what if they ran with that and had the technologies like Keolu's talking about? Maybe our Indigenous future would look better. So I want Keolu to run with that for 1 sec. If we had an Earth Guard and inter-island forces from Tahiti, Tonga, and Samoa helping us all have a better planet, see what happens there, and then we'll have a minute for questions.
You text that to me, and I really had to think about that for a while because it's such a beautiful idea. It's like, what are most technologies and economies optimized for? Profit and exponential growth. And I think at the root of that, when you think about the specializations that Indigenous people have in context of their environments, you get to these just truly incredible new forms of innovation and optimization, right? The idea of having people who really know the ocean in these intimate ways in charge of it and shepherds of it and guardians of it is a really special thing. I'll just give you an example. Who knows who John Muir is? Is he your hero? No, not. Traditionally, he is celebrated as a conservationist, the founder of the Sierra Club and many other things. And we look at national parks and we say, these are really beautiful, pristine, special places. When Indigenous people look at them, they say, this is land that I was depossessed from. It is now not being maintained in a sustainable way. The trees have grown too close together, so they're vulnerable to wildfire. And I can keep going on and on and on about what it means when you're not in communion and relationship with the land and the ocean. It's not about extracting resources. It's about maintaining the health, harmony, and stability of these ecosystems. So when John Muir ends up at Yosemite and he's like, this place is pristine and beautiful, it's untouched. The Indigenous community that is there, I think it was the Paiute, they're thinking, dude, we've been manicuring this place and maintaining it for 4,000 years. It's just so perfect and beautiful. It is invisible to you because this form of progress and innovation, you can't even recognize that pattern. You can't even see it because you're so blind. Okay. Think about that for a while when you go, but
that's a good chance. That's a good chance to let people think about this for the rest of their lives and use this in their design. Now we'll take some questions, and I know there's one, so I'm going to give it to you, and then raise your hand for if you're next.
Do you know that Hawaii has the U.S. record in autonomous car racing?
We have the record for autonomous car racing?
150 miles an hour.
Really?
Yeah. University of Hawaii, UCSD, Berkeley, and Carnegie Mellon.
Really?
Together, yeah.
Thank you,
Check
man.
it out.
I'm going to use that.
The guy in Maui.
Wow.
Yeah.
Amazing. I had no idea. That's incredible. Thank you. I did not know that.
Oh, here was an announcement, not a question.
I know.
I'll
take it.
Proud.
Yeah.
It's critical
I
information.
am proud of that.
Thank you. Anybody have a question for Dr. Fox?
Anything, guys. Anything. Oh, we got one in the corner here.
How far away?
So you were mentioning like storing data in genomes there, and like while you were in plants, I also was reading about like, well, a few things. I was reading that like I had in my global health class, we saw a documentary about how I think some of the native people, indigenous people in Arizona live with the water as their source of life, and like they're very embodiment of their culture. And in a similar way, we kind of like almost pervert the idea with the idea of the cloud in the technology industry. And we have drug-resistant bacteria that like travel through clouds I was reading about. So in theory, could we use these sorts of like indigenous ideas to instead center them as a way of storing data by using them as a literal analogy as opposed to a figurative one where we store data in the bacteria in clouds and in the hydrosphere as opposed to just like in bacteria and in plants and whatnot?
Yeah, it's good. It's very on the nose. I love it. But absolutely, I think like the promise of bioreactors, the promise of algae that produce large quantities of oxygen, and the fact that, I mean, I really think that that's probably a better value proposition maybe than plants sometimes. But but both I think we'll need simultaneously. But it's a good point.
Yep. Could you store them, like maybe have them work together through evapotranspiration between the forests and the biosphere and like hydrosphere and whatnot? I don't know how the data works there, but that could be an idea as well.
Yeah, I like connect them like in an industrial symbiotic loop. Yeah, definitely. The cool thing about plants is you can eat them. So, yeah. Anyone else?
More questions.
More questions? Was it just boring?
We'll fire. We've got a few more minutes, and I'll ask. I'll ask Dr.
There's one in the
Fox
back.
another one. So, coming to you right now.
Do you have any other ideas regarding like carbon neutral or carbon negative data storage or compression?
Yes, you got to read our papers or write me an email. But yeah, plenty. I mean, I think we're getting to the point where there's going to be just a high level of desperation around innovation in that space. And part of the reason I wanted to come today was kind of to alert people to that reality. You know, we all participate and are complicit in data storage on the cloud. We are all simultaneously addicted to data and oil at the same time, you know? But what happens in the media is we present our addiction to fossil fuels as one way, and then we don't acknowledge the other one. It's like if you're addicted to meth and heroin at the same time, don't just talk about meth. Talk about meth and heroin. Right? It's a terrible analogy, but it's kind of our reality, you know? But happy to, and I'm trying to get more of the students excited and fired up around innovating in that space, you know? So if you're looking for a gig, write me an email. Yes.
One sec, the Zoom folks can't hear you, and I need to get my steps in.
Hi, I am curious about any organizations that you know that are currently doing activism on data sovereignty, and like what that activism kind of looks like. I don't know a lot about it.
Good question. There's an organization called Enrich, and that's a partnership with NYU and Waikato University in New Zealand. There's an organization called GIDA, Global Indigenous Data Alliance. There's another one called Local Context, which is super cool. There's a big summit and conference that's going to happen at the University of Arizona in April. So there's generally a lot of interest around these things. The National Congress of the American Indian is interested. Deb Haaland, as the chief of the Department of the Interior, is interested in indigenous data sovereignty. And I don't want you guys to think that it was like my idea. I think this is an idea that is thousands of years old. It's just the context in which we're watching the digitization of everything from photogrammetry of coral reefs to archaeological sites to linguistics to hula to, you know, all of these things are being commoditized. And so people are upset about that. You know, the whole surf industry is predicated on IP from my people. It's billions of dollars. We have nothing to show for it. You know, that's sad. But hope that's helpful. Yes.
Yeah, thank you for all lectures, and I always look up to your work. It's so amazing. Here, I wanted to ask, when you work with indigenous people and when you collaborate with them, what are the challenges or what are the pros and cons of working with them together? And I feel like, when you collaborate with them, right? Like, what are the perception of getting this idea and like working together with them and creating new innovations, etc. So what are the pros and cons, challenges?
Right. Okay, so first, what I tell my students is, don't monolith people. Africa is a continent, but it's also extremely complicated. It is this tapestry of diversity in terms of culture and thought and languages and all of these things. So when we talk about indigenous people, it is never a one-size-fits-all conversation, right? I'll give you an example. In Hawaii, when we talk about the diaspora project I talked to you about in the beginning, where we're understanding our origins using our genome, we don't care if you tell us that we came from somewhere else because we knew we arrived on boats. So if you interpret our mitochondria and you say that it looks like we came from Marquesas or Tahiti, we're like, yeah, of course, right? But if you challenge people's origin stories in somewhere like Navajo Nation, that's not going to go well, right? So the application of one technology in two different indigenous communities, it needs to be thought of in terms of the local complexity of its application, like anything else. I think one thing's for certain, though. If you want to talk about people who live in harmony and have prioritized sustainability, Indigenous people are like literally millennia ahead of the sort of like capitalist Western Silicon Valley status quo. There's a lot to learn. Yeah. For a pro. That's a pro. Yeah.
One more question. You're making me think about something. There's without stepping into politics, people might know this person named His Holiness the Dalai Lama. He's a leader of a religion, maybe not a religion, a practice. And he said kind of to his European audience, he said, you're really good at this brain thing, the things that like get a whole bunch of people around to argue about and agree on. And maybe you get like a PhD in the brain, but you don't know about your minds. And you maybe as a culture like only have like a first grade education in the minds. So the Dalai Lama likes to talk to Europeans and say that Buddhism's the mind science. We have Keolu's family that's like been on the land for 4,000 years and longer, and they've been accruing knowledge and doing things, and they're still here. If you understand that Keolu's here, it means they did something right. So this is what made me think that we should really take a look at old knowledge. The people who've been around here are here for a reason, and let's like give a shout out to the ancestors and to the people who've been doing this a long time. And we're grateful to Keolu and your ancestors for being here. And why don't you shut us down with something?
Thank you so much. So I'll give you one more bit of Hawaiian. Ua mau ke ea o ka aina I ka pono o Hawaii nei. And that just means that the laws of the land are embedded in its sovereignty. Okay? And I just wanted to say thank you for everyone for joining. And thank you for having me. And if you have any other questions, please contact me by email. Thank you.